Hello and welcome to Asser's Lab again. Today we will discuss about distance sensors and how to scan your environment using different kind of approaches. We can also put ourselves into the shoes of a robot and see how does it feel if you have to rely on these sensors. Can you, for instance, build a virtual white cane so that you can scan your environment with these devices and move around. I've been playing with different kind of distance sensors and approaches. One of those being these infrared sensors that we have now installed into this small robot. Frankly speaking, they don't really work that well. First of all, they only work for short ranges, short distances, and they are easily saturated by the daylight. So you have to work, if you use them, you have to be in a fairly dark environment, and you can only see light and large enough obstacles there. Then, of course, another option is to use these ultrasonic sound-based approaches. Again, they only work for really short ranges, say up to 50 centimeters or so. Then they become highly unreliable. Again, you can't really capture small obstacles or soft materials because they absorb too much of the sound. You don't get good echo from them. And then, yeah, I got interested in these laser meters, laser-based approaches. For example, this device works up to 50 meters, so that's way more than I would need for most of my applications. And also they are fairly accurate in those measures. Yeah, while I was using this device, I thought I could hack this and connect that. To my project, I got this idea that how does it actually feel to rely on this? What kind of information you get from this device, and can you actually navigate with it in practice? So I thought it would be really interesting to have an immediate feedback from a device like this, and so that you could sense your environment, say with your fingers or your hand. I know that some people have prepared virtual white canes using audio feedback. So they convert the distance to an audio signal. I don't know how that works in practice, because if you just use the frequency as such, I think it's quite annoying. But of course there are ways to make it more comfortable, those sounds. But I was more into this haptic feedback, where you could actually sense your environment with your hands, pretty much like with a traditional white cane, where you can actually you use the stick to scan your environment a bit further away. But of course then you are limited with the length of the stick, although the white canes are of course really incredible on their own, so I'm not saying that by any means. So if you have a physical stick, first of all, it has its inertia, so you have a really good sense of the direction. If you have a small object, it's a lot harder to tell actually to which direction you are pointing to. And also with the physical stick, it's really precise. You get an immediate feedback, and you can feel the smallest surface, the smallest details of the surface. You can tell if some materials are soft or if they are hard. You can probably even hear them if you knock them, and you can tell if something is loose or connected. But of course there's also a downside. What if you touch something that you're not supposed to, and you break something or get hurt or something like that? But of course these are really precise, and you can quickly scan your surrounding, and especially if you're walking, you can feel the ground, and if there's a rock or a pothole that could ruin your day, you really feel those smallest obstacles there. Unlike if you scan your environment with a poor resolution, you may miss some of the narrow things there. If there's a wire, for example, that you would actually grab with the stick. But still, even if we have all these compromises and limitations with these sensors, it would be interesting if it's still enough for at least for some use cases. If you are in a familiar environment where you don't have some small things there, or if you, for example, navigate in a hallway, is that enough? So you can quickly move there. If you have a virtual approach, it would be really small. And yeah, of course, one advantage of a white cane is also that it's a visual indication to the others, so that it tells that this person is probably blind and may for example not follow all traffic regulations or so. It's usually a good idea to test things in practice, so that's the only way to figure out if something works really, if your ideas are viable. So I built this simple prototype. I bought a small time of flight sensor, and I connected it to this servo motor. So we have this white stick telling us how far the obstacles are. So if there's something ahead, then it moves to the right, and then if there's enough free space ahead, then you move to the left. I assembled everything into this plywood box. There was no back cover, so I actually cut a small piece from an old laptop and screwed it here. So now we have a box for the prototype. Inside of the box we have a simple Arduino Nano microcontroller there, where we have a program that calibrates automatically based on the minimum and the maximum distance measured with the sensor. So it scales those measurements for this servo motor. So because this moves some 180 degrees back and forth, and inside of this box we don't have a power supply or batteries at the moment, so we can, for this prototype, use an external power source. Let's see what happens. And now we have to point it somewhere further away and then put something ahead, and now we are in business. You can see that if there's something ahead, then it points to the right, and then if there's enough free room, then it goes to the left. And now the question is, can you actually move with this, and can you rely on this system? Is that sensitive enough, and how does this haptic feedback work in practice? And there's only one way to find that out. Let's test it in practice and move with this, our eyes closed. Okay, this bunker looks interesting. Let's see what's inside. Maybe we can test the device in here. Yeah, this is perfect. How about the other entrance? I have never been in these bunkers before, so this is all new to me. Yeah, I think these are just perfect for us. Okay, now let's see how this device performs here in this bunker. There's some space on both sides of those doors, and then there's a small room ahead. I have the flashlight on from the camera, so we can see something, but I will move with my eyes closed. So let's see how it goes. These doors are quite pretty. There they are. What about the open space? It's actually quite hard to tell. There's a small entrance. What about the other side? Now it seems that there's some free space. But yes. I actually hit the door. There's definitely something. I'll try this way. There is something. And there is something. Oh, this is scary. It's really hard to sense those obstacles on the floor. Okay, I think I'm back to the original room. Okay, how about this bunker? Let's see if we can find our way in. It's maybe easier if you follow the ceiling or the walls. the walls. What about the rocks? There's one wall. There might be here, but it's really hard to gentle rocks interactive. But the walls are easy. Yeah, I can definitely tell where the walls are. There's one. The other side is over there, and the roof. And yeah, there's nothing ahead. I can't even sense the camera. There's the wall, there's the other side. I couldn't sense the camera. I opened my eyes every once in a while just to double check that there were nothing ahead or I'm not stepping into a big puddle of water or something. we can go into these dark tunnels to test the device in the complete darkness. I'm sorry about this horrible image quality, but the night vision mode is quite poor and those infrared LEDs are too small or too dim for these conditions. So based on these experiments, it seems obvious that it takes a lot of practice to use this device. And when you move here, you can clearly sense and scan the walls and the ceiling and the floor, but you can't tell small obstacles. I think that the real wide gains are excellent for their purpose, but nevertheless, this was an interesting exercise with the distance sensors. Please leave your thoughts and comments below, and we'll see you on the next video.